Hello everyone, and welcome to Solving Right Triangles with Trig Ratios. You've probably been taught already that when you're solving a right triangle using trig ratios, you should use either sine, cosine, or tangent. Now I'm sure it might be a little difficult sometimes trying to determine which one to use. So you were probably also taught this little phrase, which might sound a little strange when you say it, SOHCAHTOA, but it's a good way to remember which ratio is sine, which ratio is cosine, which ratio is the tangent ratio. So with the first one, with the sine ratio, the second and third letter just tell you which two sides you are dividing. So with the sine ratio, you're dividing, remember O is opposite and H is hypotenuse. So it's opposite divided by hypotenuse. When you look at the second ratio for cosine, you are dividing A and H, which stand for the adjacent side divided by the hypotenuse. And then the third ratio, if it's the tangent ratio, then you are dividing O and A, which stand for opposite and adjacent. So when we say opposite and adjacent, that means in relation to one of the acute angles. So normally you're given one of the angles and you have to name the side that is opposite from the angle and name the side that is adjacent to the angle. Let's look at some examples. So in the first example, you're asked to solve for side x. And you can see that the acute angle that's given is 20 degrees. We don't have to find the other angle, and we certainly do not need to use the right angle. So let's name the two sides. So remember, when you go across from the angle, that's identifying the opposite side. So remember, opposite means across from. So if you are going to the opposite side of the street, you are going across the street. So that 10 there represents the length of the opposite side. And then x, well, that's not the hypotenuse. That is the side adjacent to the 20 degree angle because it's one of the sides of the 20 degree angle. So this side here is one side of that 20 degree angle. That's what adjacent means. It's part of the angle. Can you guess which trig ratio we're going to use here, since we've now just identified the opposite side and the adjacent side? If you're thinking tangent, you are absolutely correct, because the tangent ratio is the only one that uses both of those. So let's set it up as the tangent of 20 degrees equals the opposite, which is 10, divided by the adjacent, which is x, sets the problem up. Now, don't round your answer too soon. Wait till the very, very end to round. If you're doing homework online, either through My Math Lab or Math Excel, if you keep getting answers marked as incorrect, but you're pretty sure they're correct, it may be because you're rounding your decimals too soon in the problem. Always wait till the very last step to round. All right, now how are you going to solve this? Well, one thing you can do with trig problems is put the trig ratio over 1, so now we have a proportion, which simply means we're going to cross multiply to solve for x. So by cross multiplying, we get x times the tangent of 20 degrees equals 1 times 10 is 10. And then we're going to have to do one more thing. We have to divide both sides by the tangent of 20 degrees, which is some number. It's not a nice number, but it's a number. Those cancel there. That's 1 times x is x. So your exact answer is this expression, 10 over the tangent of 20 degrees, which now we're at the very last step. You can divide on your calculator, make sure you're in degree mode, and you get about 27.5 as the rounded value. So if you're asked for the exact answer, this is the exact answer. If you're asked to round, this is the rounded answer. So essentially the exact answer is the expression you would normally type into the calculator. And then what the calculator results, that's your rounded answer. Let's try a second example. There's 4 examples total, by the way. Here's example 2. So let's see here. We have a 30 degree angle, and we're going to assume it's a right triangle. We need a right angle there. So if we go across from the angle, that side x is the opposite side of the angle. And the 15 here represents the length of the hypotenuse. So can you guess which trig ratio uses those two sides, opposite and hypotenuse? If you guess the sine ratio, you are absolutely correct, because the sine ratio uses both of those sides, opposite and hypotenuse. So first you got to do the sine of 30 degrees equals the opposite x over the hypotenuse 15. And just like in the last problem, put the trig expression over 1 and then cross multiply. So when you cross multiply, you get 1 times x is x. Then you get 15 times the sine of 30 degrees. And that would be your exact answer. And then if you were asked for the decimal value actually comes out to exactly 7.5. You do not have to round the answer, so that is an exact answer as well. So x, side x, the opposite side, has a length of 7.5. Let's try another example. So in this problem here, we have our angle of 40 degrees. We're solving for side x, which happens to be the hypotenuse. And then side b is part of that 40-degree angle, so that is the adjacent side. So can you guess which trig ratio uses both adjacent and hypotenuse? If you guessed cosine, you are correct. Because again, cosine uses those two and only those two. So therefore, we would write that the cosine of 40 degrees is equal to the adjacent side 6 divided by the hypotenuse x. And then put the trig ratio over 1 and cross multiply. All right, so you can do the same thing for each of these problems. You put the ratio over 1, cross multiply, giving us x times the cosine of 40. 6 times 1 is 6. And then here we would have to divide each side by cosine of 40, because that's going to isolate the x. So your exact answer is 6 over the cosine of 40 degrees. And then if you're asked to round that, 6 divided by the cosine of 40 is 7.8 if you use 1 decimal place. So there's the rounded length of side x. And finally, example number 4, solve for angle theta. Remember, that's a Greek letter theta. So first, again, name the two sides. So we have a side of length 12. I'm sure you can probably guess that's the hypotenuse. The side of length 9 is part of angle theta, so that's the adjacent side of angle theta. So can you guess what trig ratio these two sides can form? If you guessed cosine, you are correct, right? Adjacent and hypotenuse is the cosine ratio for angle theta. So you would do the adjacent side on top is 9 divided by the hypotenuse is 12. So to solve for the angle, this time we have to remove the cosine there. So you probably learned about trigonometric inverses. So what you can do is take the cosine inverse of each side. So I just put the left side in parentheses. Take the cosine inverse of 9 over 12. That's the right side. And remember that there's a property here that says the cosine inverse and the cosine cancel out. But theta does not cancel, it simply drops down. So cosine to the minus 1 is the inverse of cosine, which is the opposite of cosine, and cosine itself will cancel out. So your resulting expression, the cosine inverse of 9/12, will give you, on the calculator, 41.4 degrees, or if you like whole numbers, call it 41 degrees. And that is it. So I hope you found this video useful in using trigonometric ratios to solve for sides and angles. I am the Math Musician. Please subscribe to my channel and check out my other videos. Some of them are math and some of them are music with me playing the piano. Thanks so much for watching.